Welcome everyone, I'm Alex McLeod from E&T Magazine. You're watching the IET's Engineering and Technology Magazine webinar, Today's Factory and the Road to the Future, which we're hosting in collaboration with RS Components, and we have guest speakers from TE Connectivity. So what are we talking about today? With the drive towards Industry 4 trends, the use of robotic automation and control systems on the factory floor have become commonplace to increase efficiency, productivity, and profitability. As the need for industrial robotic automation advances, sensing technology will continue to be the foundation for data collection that will help transform manufacturing floors into connected, cost-effective, and reliable facilities. TE Connectivity is a global technology leader, providing sensors and connectivity essential in today's increasingly connected world. Their sensors and interconnect products are vital to the next generation of data-driven technology. So this webinar will focus on these trends and how engineers help transform concepts into creations, redefining what's possible using intelligent, efficient, and high-performing products proven across a wide range of industries. Our speakers today are Pete Smith and Ruud van den Brink from TE. If you click on the little blue arrow by their photos on the left-hand side of your screen, you can read their bios, and if you click the blue arrow again, it will hide away again. So before we start, I'm going to briefly run us through some housekeeping. You can increase the size of the slides area in front of you by clicking on the Maximize button in the top right of the slides window. You can also press F11 on your keyboard to maximize your screen, and pressing F11 again will bring everything back. You can see a Q&A box on the right-hand side of your screen. For those watching live and the recorded version during March of 2020, please type any questions as you think of them during the webinar by typing them into this box and then press Submit. Answers won't be displayed. Instead, towards the end of the webinar, Pete and Ruud will answer some questions that have come in, and any we don't get to will be followed up in early April by an email which will be sent to everyone who's registered for the webinar to the address that you registered with. And anyone who's watching the recorded version on demand, also please feel free to type any questions in during March 2020, and we're going to be answering some of those, as I say, during this email that we're going to send. If you have additional people that you'd like this Q&A email follow-up to go to, if you click the blue Contact Us widget on the bottom of your screens, you can email me and I'll add them to my list. And if you've registered after the end of March and you'd like this Q&A follow-up, get in touch with me in the same way, and I'll email that to you from my personal inbox. That's fine. Moving on, during the webinar, if the slides aren't moving in front of you, you may need to refresh your screen by pressing F5, and for slow connections, you might need to do this regularly. Just a highlight of some of the other widget buttons along the bottom of your screen. You can open a widget simply by clicking on it and then close it by minimizing, or you can drag it, resize it to anywhere on your screen. If you're having technical issues, then please click on the yellow question mark widget at the bottom right, which directs you to our help pages. Here, please test your system, check the minimum system requirements, and review the FAQs. And if your issue is still persisting, then please submit the problem to us in the Q&A box, and we'll respond immediately. In the middle of the widget panel, you'll see a black clipboard. Please click on this to give us your feedback in 3 easy tick boxes at any time during the webinar. We'd really like to know what you think, so there's also a free type space as well. You can give us exactly what you think of this webinar. Under the RS and TE logos in the top right, you'll see a related resources list. There's quite a lot in here, and you can scroll through this list. At the bottom of the list, you'll see a PDF link entitled Continual Professional Development. Clicking this will open a PDF with advice and guidance from the IET, the Institution of Engineering and Technology, on CPD, how to keep track of it. And once you've once you've watched at least 30 minutes continuously of this webinar, either live or on demand, you can click the yellow certificate widget on the right-hand side, click the icon that appears, and you can download a personalized CPD certificate for attending this webinar. If you can't see the related resources list on the right, then you may need to click the gray widget from the bottom of your panel. Incidentally, the two resources at the top of this list, one is to TE's related page on the RS Components website about sensors connectivity, and there is a YouTube video as well, which is quite useful context for this topic, but we hope that you're going to stick with us and listen to this webcast if you're watching live. Of course, if you're watching on demand or the recorded version, you can pause this webinar while you take a closer look. The slides are not available for download. However, afterwards, you can go back in and watch the webinar again and again and again as many times as you like. Once we've finished recording this live, though, you can't immediately watch on demand. You have to wait for the recording to be available. Okay, I guess that's enough of me. I'm going to hand on over to Pete and Ron.
Hi, yeah, this is Ruud van der Brink here, and I would certainly like to take you with me on the journey of the factories of today and the road to the future. And what is a production environment all about? It is improving productivity and efficiency. And if we look back in time, there have been a number of evolutions or revolutions that basically helped in driving that productivity and efficiency. The first revolution was using steam, and steam as an energy source for production. The second revolution was the use of electricity, and basically replacing steam as a source of energy. The third revolution that we see is the use of computers in production processes and making things more efficient. And now we're at the stage where we are talking about IIoT and Industry 4.0 as the fourth wave. So what does that mean, IIoT and Industry 4.0? One of the things that is quite interesting is that in a production environment, we try to connect every device. And that means machine-to-machine connections, connections at factory level, and even higher at enterprise level, and let's say at the highest level, the entire supply chain. And what will that bring if everything is interconnected? We are able to collect data, big data. We are able to analyze it, and we're able to use it for controlling and optimizing the entire value chain. So that's in a bit what IIoT and Industry 4.0 is about. And I'd like to hand over to Pete to talk about some of the trends that are related to this.
Yes, good morning and good afternoon to everyone on the webinar here. Thank you for joining. Just to let you know, we have, between Ruud and myself, we are both experts in various fields here. Ruud is the expert for our connectivity products offerings, and I am in the sensors division, and so I am, they tell me, the expert in the sensors area, and Ruud and I will be going back and forth as we speak to each one of these slides and bringing our own level of expertise to the connector features, and I will be bringing the sensor commentary here. So we'd like to start and talk a little bit about some of the trends that we're seeing. As you might expect, customers are coming to us and they're implementing these IIoT concepts and strategies into their factories, and they have a need for our products, both from connectors and the sensors groups. And they're asking for some very specific things for us to do with those particular products. And there are some trends that we've identified that are very important, and we think they're going to continue. And we're going to go through a review of these trends. This is a brief summary on this slide of the trends, and then we're going to show slides that discuss each one of these in a little more detail. But the major trends that we are seeing are, and I'll go through them quickly here, miniaturization is one thing. As with all products that you see today, they're trying to make them smaller but they're at the same time, they're trying to fit more features into the products. And so the result is the components that go into these products, there's a tremendous effort to make them as tiny as possible, but give them as many functions and features as we can. Digitization is another trend we're seeing from the use of computers, as Rude pointed out, in the factory, everything that operates digitally. And we'll talk a little bit more about what that means from the sensor perspective here when we get to that slide. Low power is another trend that we're seeing, and it applies primarily to the connector products. There are many applications in a factory where it may not be possible to bring electrical power to the sensor. And so the result is that the sensor has to be self-powered in some way, and then oftentimes that means batteries. And so when we have battery-powered sensors, the low power feature is very important to extend the battery life as long as possible. There are some products out there now that can have a battery life of 5 to 10 years without too much difficulty, which means these sensors are operating at microwatt levels. Multi-sensor modules is another trend that we're seeing where customers are asking us to combine the sensor techniques and sensor technologies into a single package, where and we'll show you some examples of what that looks like and what kind of applications they fit into. And finally, harsh environments. Because IIoT, the fundamental feature of IIoT is you're trying to collect data, and you want to collect data, and you're using sensors to do that. And so to get as much data as possible, you want to put as many sensors out there as you can think of that provide pertinent data. And oftentimes we're seeing our customers put these sensors into places that really aren't so friendly to sensors. They may have a particular application where the sensors are going into high temperature areas, or there might be hazardous materials. But we'll talk a little bit more of that in detail. But we are being asked to package our products from the connector side and the sensor side into packages that can withstand these very tough environments. And so I'm going to move to the next slide here, and we'll talk a little bit about in detail what some of these are. Rude, I'll start here on this one, and then I'll pass it over to you to talk about the connector features here. The first trend that we see is the trend of miniaturization. And as I said, customers are asking for smaller and smaller form factors. They're trying to pack more and more electronics into smaller packages. I don't know if any of you have ever seen, you can go onto YouTube and you can see teardowns of various products. And one of the most revealing is a teardown of the Apple iPhone. And as they take that apart, you can see how much technology they're putting into a very small package. It's very interesting, and it's actually pretty amazing. And so across the board, we're seeing that kind of pressure from our customers to provide these smaller and smaller packages. They are shrinking. They're asking for more content, more capability, and the interconnect devices and the sensors are experiencing the same requests from our customers. What that does to us is it drives innovative packaging. If you look down at the bottom, you can see some of the sensors that we make. The smallest sensor we make right now is shown in the center. It is the TSYS03 temperature sensor. The smallest version of that is 1.5 by 1.5 millimeters square, and it is 0.4 millimeters thick. But inside is a temperature sensor, a microprocessor, and a communications chip that communicates all the data back to a controlling computer or microprocessor. Most of our sensors for these kinds of applications fall into that space range. Some of the others are 3 millimeters square by maybe 1 millimeter tall. The way we do it, and we show it on the right, if you take a standard electronic sensor and you take it apart, you can see that there's several components inside. There's an image there that shows the elements are all side by side on a small substrate. What we're doing to make the sensor smaller and occupy a smaller footprint on a printed circuit board is to take all those elements and stack them up. Rather than lay them side by side, we can actually put a sensing element on top of the microcontroller chip, and we build a little tiny stack of components inside the product, and we can shrink these sensors dramatically. Ruud, can you address the issues regarding our connector products?
Yeah, absolutely. Thanks, Pete. If you look at the picture on this slide, that basically gives a good example of two technologies that we see used in industrial. You see the bigger connector that is an RJ45, and this particular connector here is made for the industry, so it is much more robust than the full plastic connectors that you see used in an office environment. And by having that ruggedness, of course, it is coming with the disadvantage of that the connector basically grows. Yeah, it's a lot more bulkier than the connector you will find in the office environment, and that is not helping with the miniaturization of things. That is also why TE has brought a number of alternative connectors to into the world, and the one that is shown here is Mini-IO. And if you look at it from a size point of view, the frontal area is roughly 25% of what is standard being used by an RJ45. So that allows you to build smaller products. If you are using multiple interfaces next to each other, you're able to use less space. And due to the reduced height of a connector, you can, for instance, make blades in a rack-based system which are about 15 millimeters apart. So it basically helps in scaling down the system in many, many ways. From a ruggedness point of view, we have special contacts basically in that connector family that helps to keep the connectors together, even in an environment where equipment is used with heavy shock and vibration. So not only smaller, but also outperforming in that type of performance. And I would like to take it to the next topic. I don't know, Pete, do you want to kick this one off as well?
Okay, I will. This is kind of an obvious one. One of the trends that we're seeing is digitization, and the reason it's a little more interesting for the sensors suppliers is that the sensor industry has been a little bit late to the digitization. Most of the world, as you all know, went digital probably 20 or 25 years ago. Well, sensors has not kept up with that. In many cases, the sensors that have been used are analog output, and with the use of microcontrollers that have A to D converters built in on the inputs, the customer was able to convert that analog signal to a digital signal and then process it through his microprocessor. Well, what's happening particularly in IIoT is that those events take time, and one of the big problems that the factory in IoT faces is latency. It's a term that's where it's the delay between the sensor detecting a condition and the time that the system takes action to correct it or do something in reaction to that sensor. And so they're asking us to put digital features into our sensors where we communicate over digital networks, and it increases the speed of reaction from sensor input, and it helps reduce that latency issue that the factory people face. Everything we do now is we offer it in both an analog and a digital version. The preferred protocols that we're seeing now are I2C and SPI. Those are the primary ones that everyone seems to focus on. They're kind of becoming a standard across the world for digital communication. We do offer other kinds of communication. We have devices that can communicate on Modbus, on We even have some in the automotive industry that are using scent. We even have a couple that go way back to an RS-232 communication technique. So we can provide a variety of interfaces. The advantages, of course, are that their digital output is more compatible with microprocessors and digital circuits. One advantage in the sensor is that if you digitize the signal very quickly in the sensor, you get much better performance. You get much higher resolution of the sensor and better accuracy from it. And digital sensors draw much less power than analog sensors. So there are a number of other advantages that are moving to digital provided to the sensor world. Okay, Ruud, go ahead and talk about the connector implications.
Yeah, from a connector point of view, if you look at the traditional automation networks, you see a variety of different technologies being used. On the factory floor, it's often serial communication that is basically topped by a layer of bus structures like the traditional field buses, Profi bus, for instance, as an example. And the most highest layer in such a network are normally using Ethernet connections, so with the standard RJ45s. So that's like a three-layered approach, and that is a very inefficient way of organizing your network. You can imagine that between every different communication protocol, you have your gateways collecting information at one side, basically converting it to a bus protocol, and then on its turn in the next step, converting that again to Ethernet. That is basically costing you a lot of delay. That is one. You need to be sure that with the implementation of such gateways, you have all the information passed on to the next layer in your network. And from a manageability point of view, you have the equal share of problems. So what is a good solution for that is to drive the digitization over your entire network, make it all Ethernet, as we say it. And that means have connector technology at the field level, which is able to deal with Ethernet. And there's an example on this slide, field installable M12 X-coded. The M12 family is very much suited for, in the old style networks, serial communication, bus communication, and Ethernet. But let's say in the newer network structure in IIoT, the M12's decode and Xcode are, let's say, the Ethernet variants of that family that will be used on the factory floor. So that gives you an IP67 solution, dust-proof, waterproof, and fully Ethernet capable, and especially with the Xcode up to speeds of 10 gigabits per second. So that will cover the future quite nicely. RJ45 Mini I/O can be used in conjunction with those type of technologies in the M12 space. And if you look at the other picture that is shown there, we see to the future single pair Ethernet as a new network technology basically picking up. And that combination of different connector styles allow you to build a network that is fully Ethernet based. And of course, together with Ethernet, you have Internet protocol, so the manageability of that network can be done over that Ethernet infrastructure quite easily as fully IP addressable.
Okay.
So I hand it over to Pete again.
Wait a minute. We both hit it at the same time. Here we go. The next thing we're seeing is, from the sensor perspective, is low power. Many sensors are finding their way into areas where it's difficult to supply them power, and or it's expensive to run powered wiring to the sensor. So what we're doing is we're introducing self-powered sensors now. In many cases, they're battery-powered. In some cases, they use energy harvesting, where they're pulling energy from another source that's local and can use that to power a sensor. But in those cases, the lowest power possible is a huge advantage because if it's batteries, it extends the battery life we want to extend that out to years. And if it's energy harvested, most energy harvesting that you find in a factory can provide a little bit of power, but it's not very much. So we've re-engineered many of our sensor products to operate at very low power levels. Digitization has helped that, as we talked about in the previous slide. But some things that you can think about, sensors oftentimes don't need to be operating continuously. If you're monitoring a liquid level in a tank, for example, you don't need to continuously monitor that liquid level. You could take a reading once per minute, for example. And taking a reading with a digital sensor only takes a few milliseconds. And so every hour you consume a tiny bit of power to power up the sensor, take the reading, and then send the data to the control system. And then the sensor goes to sleep. So many of our sensors have a sleep mode built in. And in the sleep mode, they consume nanowatts of power, very, very tiny amounts of power, just to keep them alive. And then they wake up and do their job for a few milliseconds and then go back to sleep. So most of our sensors now can have this sleep mode capability built in. It's ideal for battery and energy harvested applications. Ruud, go ahead and talk about the connector.
Yeah, exactly. It is hard to talk about low power if you talk about a connector. We tend to refer to easy power distribution rather than having a separate power connection to every device. You can use your network cables and connectors to get that power into your sensors or into your actuators. And there are different technologies for that, each with their own set of advantages and disadvantages. And on this page, we have basically indicated a number of power supply options. And if you look at the jack, it is basically supporting power over Ethernet, and that is similar for our M12 metric circular product family. And what you basically do is you combine the signals with power on the wire pairs of that particular cable, and at the remote end you are able to use that energy to power either your access point or your sensor. And with power over Ethernet, especially with the latest generations of that, you are able to support about 100 watts of power. So that is tied to the traditional RJ45 jack and M12. Then if you look at, for instance, the four technologies, a single pair Ethernet, of course, if you have only one pair of wires in your cable, then there is only one set that can be used in supplying power. The protocols that go hand in hand with that are called power over data line, POODLE. And those protocols support up to 50 watts of data that you can basically get over a cable and a connector combination. If that is not enough, TE has an alternative, which is in the form of a hybrid M8. That means that next to the signal pair, you have a pair of additional wires that can supply up to 8 amps to the equipment. So that allows, for instance, systems have a high requirement for power to be built and to be remotely powered. You can also think about multi-drop environments where especially the first portion into that multi-drop environment is carrying a lot of current. And it is basically allowing you to effectively get 200 watts in your equipment, and because it's an M8, it is IP67 graded, so it is dust-proof and it is waterproof, and that would be an excellent solution on the factory floor. And then I'd like to hand it over to Pete again.
Another trend we're seeing and the customers are asking for are what we call multi-sensor modules. Essentially what those are sensor packages that contain more than one sensing technology inside of them. And here's some examples of some of the things that we've done in that area. Starting on the left, we make a relative humidity sensor. It's very tiny. It's 3 millimeters square. It's 1 millimeter tall. It's digital. But inside is not only a humidity sensor, but it is also a temperature sensor. So we've combined relative humidity and temperature into a single package. The advantages of this is obviously a space savings on the printed circuit board. It's a smaller footprint. And it has another interesting advantage. We've got a single sensor here that is actually providing two pieces of data. It is providing the relative humidity and the temperature. And then when you have those two pieces of data, with a little bit of calculation in your microcontroller, you can calculate a third parameter. You can calculate dew point. And so with this one sensor in a single package, it has two sensing elements inside. You can get three pieces of data from it. You can get the relative humidity, you can get the temperature, and you can get the dew point with a little bit of calculation. And so this is the idea of multi-sensor modules also provides logistic advantages for the customer. He does not have to buy two sensors here. He only has to buy one and carry one in his inventory in stock because the two sensing elements are combined. The next one over, MS8607, actually is an expansion of that. It's a very small product. It's 3 millimeters by 5 millimeters by 1 millimeter, very tiny size. You can fit probably 5 of them on your thumbnail. But inside is a relative humidity, a temperature sensor, and a barometric pressure sensor. And all of the data from those three sensing elements is available over the I2C interface. And because you, again, know relative humidity and temperature, you can calculate the dew point. So with this one sensor in a tiny package, you get 4 pieces of data from it. The next one over, HTD 2800, combines, again, the relative humidity, temperature, and barometric pressure. That is in a package that's specifically designed to go into intake manifolds of internal combustion engines, diesel or gasoline, where they're monitoring the relative humidity of the intake air, the temperature, and the barometric pressure of the intake manifold. And they send all that data to the engine control unit, and it optimizes the fuel ratios that they inject into the cylinders. And it improves the fuel economy of all these engines. But again, it's a single package that the customer buys from us and installs it. He's getting a couple of three different sensing features from it. And finally, on the right is one of our super tiny altimeters, where it's a pressure sensor and a temperature sensor. It's about 3 millimeters square, about 1.5 millimeters tall. And there's a digital interface that connects all this. These are used in places where space is a premium, where you just can't fit things in. One application for it are the watches that you wear, the fitness watches. Use these kinds of sensors in them. It's not really an IoT or an industrial IoT application, but it gives you an idea of the places where these can find themselves into very small products. Okay, I'm going to move on to the next slide here. What we're seeing in another trend, as I talked about before, is customers are trying to put sensors in places that are really not very friendly to sensors. You can see some of the images here. Steel mills on top. There's a tremendous, they're not clean areas, they're dirty. They've got debris everywhere, the high temperature, they've got smoke. It's not a very friendly place, basically. Not only it's not friendly to sensors, it's not friendly to humans. So we have to package our sensors in a way that they can survive in these kinds of environments, and we do a really good job of doing that. Ruth has talked a little bit about IP ratings for some of the connector products. We put IP ratings on our sensors. We have some that many are IP67, some are IP68, and then even we have a line of products that are in fully hermetic packages. to fit into very, very harsh environments. But you can see there's steel mills, water treatment facilities, particularly wastewater treatment facilities, are very, very aggressive environments for sensors. Petrochemical processing factories are another place where the sensors typically are outdoors. And believe it or not, outdoors, we all like being outdoors, but it's a really harsh environment for sensors because they have to withstand all the variabilities of weather and the things that go with it. But the major areas that we're seeing the harsh environment is aggressive liquids and gases in chemical processing, for example, hazardous and explosive atmospheres, again, in the oil and gas industry, when they're doing refineries, high vibration levels and mechanical shock. Ruth has talked about that a little bit for some of the sensor products that we have. Some of the connector products, Extreme temperatures, both cold and hot. Very strong EMI, RFI, and electrostatic fields can exist in many of these, and that's considered part of a harsh environment. And we put shielding around our sensors to make sure they can survive that. And then we even have some sensors that are radiation hardened to go into areas where there might be radioactivity, typically nuclear generating plants. But another area is in medical equipment that uses radiopharmaceuticals for treatment of certain diseases. They use radioactive sources to treat things like cancers. And so it's important that the sensors in those applications can withstand exposure to high radiation environments. Ruud, are there some things you can talk about with connectors in the harsh environment space?
Yeah, sure, Pete. I think if we look at the former connector families that I introduced, I think if we look at RJ45, that is where we start. Connector coming out of the office world and being used in Ethernet connections in the industry. And that basically made or introduced a lot of changes to that connector. So the interface style is still an RJ45, but you see that the connector in general is much more rugged and stronger than what you find in the office environment. Take, for example, metal latches on the device, using materials that can withstand higher temperatures. The ease of installation is also something that in the industry is absolutely appreciated. If you need to build a connection there, have a wire sticking out of the ceiling or sticking out of the wall, and you need, in an industrial environment, you need to terminate it, you need to do it quick, and you need to do it in a way that the connection is guaranteed to function. So we design products for doing these kind of things in that space. If we then take it one notch further, the Mini-IO, specifically designed for industrial environments, is going one step further. It's not only smaller, but the fighting snake contact style that is in the Mini-IO makes it extremely suited for environments with heavy shock and vibration. And because of that contact technologies, you won't see the micro interruptions that are taking place in case you would have had RJ45 in a similar environment. Not only shock and vibration is something that Mini-IO is addressing well, also things like shielding, and Pete already touched on it, EMI, quite important. Keep all of the disturbances out and away from your signal lines. We are designing the products with a 360-degree shielding. That is Mini-IO, but also in the M12 family, and that is keeping a full shielding and extending the shielding of the cable and keeping all the interferences out. Then if we look at the M12 connector range, I think that one is having some product features on top of what we have in Mini-IO and RJ45, and that is, of course, the IP67 shielding. Dust-proof and waterproof connections, I would say, make it very suited for those harsh environments, and especially on the factory floor, where all of the hostile influences are at a maximum. Well, let's hand it over to Pete again. on the application
Okay.
side.
For the smart factory, IIoT, the applications that we're seeing primarily right now are in the area of robotics, and in control cabinets, servo drives, servo motors, various kinds of machinery, in-out modules. The main thing that we're seeing is that the sensors are being used for condition monitoring. You can put a sensor on an electric motor, and with a couple of sensors, you can check the health of the electric motor almost on a continuous basis. For an example, for a good system for a motor, we put temperature sensors on the bearings. We put an accelerometer or vibration sensor on the motor, so if anything goes out of balance, we can detect it very quickly. And then for acoustic emission, we can actually listen to the motor with a special contact microphone. And as a motor begins to fail, it starts to make unusual sounds. And we listen to those sounds, and we provide that high fidelity capability for the acoustic situation in the motor. Most motors, just like humans, when they start to fail, they start making noise. And so you want to listen very carefully to them. And so what we're seeing primarily is machine condition monitoring. We're checking up on all this equipment just to make sure first it's operating correctly, it's meeting the parameters that it's supposed to meet in terms of temperature or pressure or force or whatever it's doing, but then listening for unusual events that might occur. One sensor we just introduced into the robotics area is a torque safety sensor. It goes into the rotating parts of a robot, the elbows, if you will. And if it's a torque sensor, and it can measure the torque that is being applied to that elbow. And if any unusual torques appear, for example, the robot runs into something, or there's an object, it's in the way, and the robot hits it, the torque will spike to a much higher level. And the sensor detects that, and it will send a signal off, and the robot will stop its operation and many times retract to a safe position. So these are the kind of applications where our sensors are adding a high degree of safety to the factory, particularly in cobots where the robots and humans are working side by side. And in some cases, the humans are actually wearing the robot around them to increase their strength or their capabilities to perform their duties on the factory floor. And then, Rude, how do our connectors fit into these?
Yeah, exactly. I think we see similar type of things in the connector space. If I, for instance, pick out robotics as an example, sheer size of the connectors that are basically in all of the different parts of the robot and interconnecting the internal wiring. You can imagine that space comes at a premium. You have an environment where heavy acceleration and deceleration is taking place. So shock and vibration need to be in good shape. And if we're very lucky, then of course the robot is completely sealed. So IP67 grading is less of an issue. But we see, for instance, products like Mini-IO being used in those environments for that particular reason. And if I take it one step further, we see similar type of requirements coming from servo drives. Often they are tied to the motors itself, and also then prone to shock and vibration. I would say the M12 family in combination with Mini-IO are absolute good solutions to be used in such applications. Then more generically speaking about machinery, that is where we see a heavy amount of M8 and M12s being used, guaranteeing the IP67 rating in an environment with dirt and moisture, and shock and vibration covered as well in that particular product family. So I think, all in all, we have the solutions for these type of applications from a connector point of view, addressing those major problems as EMI, as high temperature, so environmental and shock and vibration.
And I'm just going to interject here as well, just while you guys are finishing off your last phase, just to remind everyone that if you have any queries or questions, then by all means put them into the Q&A box on your right-hand side, and we'll get to a Q&A session in a little bit, but I'll let Pete and Ruud carry on.
Okay. Thank you, Alex. We've got a couple more slides here that specifically address the different kinds of sensor technologies we're seeing being introduced into IoT and factory IoT. I'm going to go through these fairly quickly here, but just to give you a flavor of the kind of sensors that are being implemented here. TE makes all of these sensor technologies. We start with our temperature sensor line. We have a wide variety of temperature sensors in chip form, in probes, in various ways that are attached to machinery. What's interesting about temperature is the second most measured parameter in the world. More temperature readings are taken every day than any other parameter except for one. One other thing is measured more often, and that's time. People measure time more often than temperature, but nothing else exceeds temperature. We make pressure sensors that go into various applications for hydraulics, liquid pressures, liquid levels. Various kinds of applications are our humidity sensors, and most of those have temperature sensors built in. And monitoring humidity in factory environments. Force and load sensors, very popular, where we're measuring the forces that machines apply to factory processes. And we make a wide variety of those devices. And as Ruud has talked about the packaging, and many of our force and load sensors come in hermetic packages. So they can operate in very, very harsh environments. We make some multi-sensor modules that we've talked about already that go into applications. We make position and motion sensors. These are sensors that use a magnet along with it. The magnet gets attached to the moving piece of the equipment. The sensor is stationary, and we can tell you many things about the motion. We can tell you which direction it is. We can give you 3D motion data. We can tell you how fast an object is moving, how fast it's accelerating or decelerating, or if it's not moving at all. So by just the introduction of a magnet on the moving part and this sensor, we're able to determine all that. Liquid level sensors in a number of factory applications where you have tanks that may contain chemicals or material that's introduced into a product. If you're, for example, if you're in the food processing industry, you're putting various kinds of liquids into cans and bottles, for example, and you want to measure and keep track of the liquid level in all your tanks that supply the factory line. And of course, accelerometers and vibration, very popular in machine condition monitoring to measure various parameters of the machine. And then, Ruud, there's a bunch of connectors that I'll let you talk about.
Yeah, exactly, Pete. And I think that these are absolutely the connectors for an IIoT environment. To start with the connectors on the right-hand side, the industrial RJ45. You see the RJ45 jacks. What we basically equipped with extra thick gold layers to have a very good corrosion-resistant contact set, to use high-temp materials, to be used in high-temp environments, but also matching a lot of the production processes in reflow soldering. So both on the board side as well as on the cable side, we basically try to tune our connectors. If you then look at the other picture next to that industrial jack, you see the traditional IP20 RJ45. And then there is some other forms as well in the form of bayonet closed or push-pull style connectors, and that particular surrounding, or let's say that the shielding around the RJ45 interface is guaranteeing an IP67 grade as well. It is a little bit more bulky, but you can use a traditional RJ45 with that additional. Then if you look at the left-hand side, you see the Mini IO. That is basically a product family with very, very small SMD board connectors, and that allow you to build very dense systems. As said, almost 25% the frontal area of an RJ45, so that helps a lot. Specific contact families to help with reducing the issues of shock and vibration. And then at the same time, these small connectors are supporting the transmission speeds up to 10 gigabits a second as well as with the standard RJ45. On the top, I would say on the left-hand side, the M8, M12 circular connectors. We got a very, very broad offering there in this IP67 rated connector family. Very well suited to address the serial field bus as well as Ethernet traffic in the more traditional industrial network buildup, as well as moving forward the Ethernet D and Xcode products, which are brand new from an Xcode point of view, and are, let's say, the market best in ease of installation. So we've been improving and slightly older M8, M12 connector family to fit the requirements of today's installer. And then on the right-hand side, the right top-hand side, the SPE single pair Ethernet connectors. On the left-hand side, an IP20 connector, and on the right-hand side, an IP67 M8 hybrid connector, addressing the various applications in that space. IEC certified, 63171-6 is supported, and we have an industry and single pair Ethernet association driving the standard with other players in the industry.
Okay, that's our presentation. A quick summary slide here. Just to review the role of sensors and interconnects in IoT. And as you all know, the industrial IoT, it's a whole ecosystem of devices that are out there, and the connectors and the sensors are very critical. The sensors are necessary because without the sensors, you have no data, and without data, the IoT system is useless. And that data has to be connected back to a central processing capability that can evaluate the data and make decisions, provide information to the users, and essentially do a checkup on your whole factory on an ongoing basis. What we're trying to do is we're trying to bring dumb, and this is, I love the way this is worded, it brings dumb devices to the smart level where they can participate in the digital world. That's what we're doing to a factory. We're taking all those motors and machines and stamping presses and various kinds of equipment out in a factory. We're making them smarter by adding sensors and connectivity to them so they can participate in the digital world. It's a very important aspect of it. They're critical, again, sensors interconnect, very critical parts. We listen for and collect the data about the application, monitor the environment around the devices too. And so the result is you can keep your factory safe, you can keep it healthy by making sure that you pay attention to if you detect a machine that's beginning to fail with the sensors and communicating that information back. You can schedule maintenance and downtime without having catastrophic interruptions in your factory. So it's very important. We feel that we're supplying very important features and capability to people that are implementing these kind of systems. Ruud, anything you can add?
Yeah, if I talk about interconnect in such an environment, I always look at the analogy of oil transport. Consider oil to be the data. Well, what is the interconnect? We are the pipelines that basically transport that data. And that should, of course, be without any leaks, and it should be having the right capacity. And that is what we bring as interconnect in the IIoT world.
Okay. Alex?
Yeah. Are we ready for some Q&A, folks?
Yes.
For sure.
Okay, excellent. So we've had quite a few questions come in, but everyone who's listening, if you think of something else that you want to ask Pete and Ruud, something that we can either answer whilst we're live on the webcast right now, or if it's something you would like to know more about as an afterthought with some additional details, then please put your queries and questions into that Q&A box. Okay, I'm going to kick off with this one. This is a sensor question, so Pete, I guess this is more for you. A question is, can you comment on the relative accuracy of the digital temperature sensors compared to the traditional RTD types of temp probes using analog 4 to 20 milliamp interface?
Yes, traditional RTD type temperature sensors are available in several accuracies. We provide analog products, and I think the accuracies are 0.1 degrees C, 0.2 degrees C, 0.5 degrees C, in that range. And in many of our sensor products, we take the RTD signal and we digitize it. And what we're doing is we're having a tremendous amount of resolution in these things so that we can get very accurate readings through the digital domain. We are typically using 16, 18, and 24-bit levels of digital resolution in these things, so we can achieve similar accuracies within the digital world as you get from analog world. It's not difficult to do, and the primary feature that we do to achieve that are high resolution, many bits of resolution. So yes, to answer your question, the digital sensors can be just as accurate as the analog products.
Okay, I'm going to choose another one here. Let's go for a connector one. Is TE willing to develop custom connector solutions for customers, and or are small product changes supported?
Thank you for the question. What we're already doing today is we are, as TE, developing connector families that are compliant to standards being used in the industry. And if you talk about a connector, that is the interface portion of that is standardized. A connector has, of course, not only the interface, but in case of a cable connector, you have the wire termination. In case of some board connector or panel mount connectors, you have the form factor in attaching it to a panel. Those are the areas where there is freedom to design and still comply to the industry standards from an interface point of view. And we are actually working with our customers together to either advise them on a standard solution, or if that is not possible, to see what the customization options are. And of course, it depends on how radical those changes are, under what conditions that can be done. But in principle, we're willing to look at any of those type of opportunities.
Okay, thank you very much. Pete, I'm going to swing back to you here. Someone's picking up on your slightly amusing thing of the dumb devices. So the question is, what type of sensors would be allowing dumb devices to work with the IIoT?
Okay. Let me address that. It's kind of a two-part answer. If you walk into a typical factory, there's all kinds of machinery around. And if you think about it, there's really two environments that machinery. Take a typical electric motor that's in a factory. and it's just sitting there and it's running. And basically, it's dumb. It can't tell you anything about itself. It can't tell you anything about if it's doing a good job or not. It can't tell you anything. It's just basically stupid. And so when you start to add sensors to it, you give it some intelligence. And there's two areas of intelligence that you want to collect from any machine out in a factory. The first is the machine doing its job properly? Is the motor providing the appropriate torque to the equipment that it's powering? You put a sensor on that, and all of a sudden, you add some intelligence. You make it smarter. It says, hey, I'm doing my job, but I'm doing it properly. I'm providing the right amount of torque or the right speed to the machine. And so that makes the motor smarter. But there's a whole second area of monitoring that you do with sensors, is you provide sensors that do a checkup on the motor itself. Like my windings, is the temperature right inside my motor windings? In other words, it's a self-checkup of the motor. Am I healthy? It's a health checkup. It's like going to the doctor. And it's just like a human. You have sensors in your body that detect the environment around you. You know what the temperature is. You know what the weather's like. Just with the five senses that you have, you know what your environment is. But you also have a sense of your own health. If you don't feel good, you know you're sick. You're sensing those kind of things too. So you apply those same two things by adding sensors to a dumb equipment in a factory. And as I said, a motor. You make the motor smarter about how it's doing its job and how it's interfacing with its environment. And then you also make it much smarter by giving it the capability to keep track of itself. It can tell you if it's healthy or not. And so that's the big advantage of adding these sensors. And the sensors in a typical motor will be accelerometers to monitor vibration, temperature sensors, acoustic sensors that listen to the motor. It gives you all this capability to tell you that motor is healthy and it's doing its job. So it's a huge advantage to the factory because it improves efficiency, throughput. It allows you, if the motor does need maintenance, it allows you time. Oftentimes these systems will say, okay, there's a motor out there that's not working right, and it's going to fail within the next 1,000 hours of operation. They can actually get to that level where they can predict the failure of a particular motor just by monitoring its parameters. And so that capability, they can schedule downtime to go maintain the motor, do maintenance, or replace it if necessary. But it does not disrupt factory operations, which are highly integrated these days. And anything that stops working, the whole factory comes to a screaming halt, and it's a huge problem, extreme costs. And so that's what we're doing here, and that's how we're making equipment from dumb to smarter. Hopefully it'll be really smart. I'm hoping one day that the factory machine can go out and get me my lunch and bring it back to my desk. We're not there yet, but I hope it's coming.
In the UK, we often have a phrase of anything technological, and consumers in general will say, well, can it make me a cup of tea?
Yeah.
So, yeah, you're exactly right. You're exactly right. We have many more questions. I'm sure we could carry on this webcast for probably another hour with all the questions that have come in. So thank you very much for everybody who's submitted a question. And again, I can't reiterate enough, if you're watching this on the recorded on-demand version and you have a query as well, then especially during March of 2020, do put that into the Q&A box, and we'll be sending an email to everyone who's registered for this webcast in early April sometime with a really nice follow-up to this session. I think it's been really good. So I'm going to wrap up now, folks. Thanks again to Pete and Ruud, and thank you to everyone who's joined us to watch, listen, and indeed contribute. And yeah, as I say, any unanswered questions will be followed up, and I'm sorry, we've just not had enough time to reach them today. So yeah, what's going to happen next is you'll get an email about the webinar, and you can access this webcast again through exactly the same link and watch the recording and on-demand version. You don't need to do anything else. The webinar platform will be unavailable just while the system prepares the recording, so you may want to give us until 6 p.m. UK time if you're really keen to watch this back on the 5th of March 2020. So yeah, thanks very much for watching. We hope that you've enjoyed the presentation and will join us for the next Engineering and Technology Magazine webinar. But I'll hand back over to Pete and Ruud to say their goodbyes and thank yous.
Pete, do you want to go first?
Yeah, go ahead. Ruud, go ahead if you want.
Yeah, I'd like to thank the audience, also the organizers. Thanks very much for attending this webinar. I hope that it was interesting and gave you a little bit of a glimpse of what IIoT is like and what TE is doing from a connectivity point of view. So the open questions will certainly be answered over the next foreseeable time. And thanks again, I would say, and I'd like to hand over to Pete for a final word.
Okay, and I'll echo what Ruud said. I thank you for all your time. I'm sure you're all very busy, and there's a lot of things going on where you are. So to take the time to listen to this, we certainly appreciate it. And I urge you, there's a lot of people out there that are turning their factories smart, and so get busy and start turning your factory into smart also. Because it's going to be a very competitive advantage for most facilities out there. It's, as we pointed out in the beginning, it's the next revolution in manufacturing. So we're ready to help you. And if you have questions, the questions that you've asked, I think Alex pointed out, will be answered in emails or communications later on. So we're not leaving you high and dry. But again, thank you so much. We appreciate your time.